Thanks for tuning in. I'm presenting listener sensitivity to syllable complexity in speech tempo perception. I'm Leendert, and this work was done with Robert Lennon and Rachel Smith and supported by the Leverhulme Trust in the UK. We're reporting here on one in a series of studies aimed at improving our understanding of how speech tempo perception works, and in particular, to what extent listeners show sensitivity to the segmental makeup of utterances. Speech tempo is often approximated through measures like syllable rate and segment rate, but in languages that allow complex syllables, these measures are not necessarily perfectly correlated with each other. So in English, we know that more complex syllables are longer than simpler syllables, but typically they have lower average segment durations within them. So complex syllables contribute to a lowering of syllable rate, but a raising of segment rate. Now, work on speech tempo perception has tended to correlate either syllable rate or segment rate with tempo judgments elicited through listening experiments. Pfitzinger included both rates in his analysis, and his analysis modeled tempo perceptions by German listeners listening to spontaneous speech materials. His final model contains both rates, which suggests that listeners orient both to a beat rate of some kind captured well by a syllable rate measurement and to the numbers of phones between beats captured well by segment rate. And we've tried to follow up on this with experiments in which we carefully control the variation in the two rates in the experimental design, crucially including stimuli that are constant or close to constant in syllable rate, but variable in segment rate. So we've reported on several experiments using phrases like the ones on the slide here, in which we varied the phonological complexity of the nouns. So kit, pack, trust, stock. In the first experiments, we controlled syllable rate by equalizing the durations of these phrases. So listeners heard a pair of phrases, like the one on the slide, with the same syllable rate, but different segment rates, because in the case of this pair, trust and stock on the right have complex syllables, while kit and pack have simple syllables, and listeners were asked to judge whether the two phrases differed in tempo. Now, in these experiments, listeners didn't hear much difference between these phrases, so we found no evidence for orientation to segment rate. However, in a subsequent experiment, we included 3 different phrase shapes with different syllable numbers. So we controlled syllable rate as we did before, but because of the different phrase shapes, phrase durations were variable. And in this last experiment, we did find evidence of listeners' orientation to the differences in syllable complexity in the nouns captured by segment rate measurements. And it confirmed, and the findings for this experiment also confirmed, that listeners pay close attention to stimulus duration when judging tempo, with longer stimuli being judged as slower. So our hunch was that in these first experiments, we'd made the stimuli too uniform for listeners to pay attention to segmental differences, and experiments with more variable and therefore more naturalistic stimulus sets might reveal further evidence for sensitivity to segment rate. We followed up on this hunch with an experiment that we report on here using stimuli sampled from a corpus of unscripted speech. Now, the experiment was embedded in a larger experimental design in which 55 listeners judged the tempo of 180 stimuli. And here I'm talking primarily about their judgments for 60 stimuli, which were presented in one separate block. We selected stimuli from a collection of 920 short stretches of speech that were extracted from the Divers database by Erica Gold, who used these 920 stretches as a working corpus for her PhD, to which you'll find a reference in the paper. And you can also follow the reference for the larger Divers database as well. In simple terms, the materials we're dealing with here are speech materials produced by 30 male speakers of Southern Standard British English doing various role play tasks. We processed all the stretches using WebMouse, and we calculated the syllable and segment rate of each stretch based on canonical syllable and segment counts. Now, across the 920 stretches, syllable and segment rate were not perfectly correlated, as expected, but the correlation was still close. So to come up with a stimulus set in which the two rates vary independently to some extent, we identified three narrow quantile ranges in the distribution of each of the two rates, which you see plotted here against each other in the scattergram. So one 10 quantile range towards the bottom end, one around the mean, and one towards the top end. And within each of these 6 quantile ranges, 3 for each of the 2 dimensions in the scattergram, we identified 10 stretches, 10 data points, for whom the rate on the other measure was as widely dispersed, for whom the rates of the other measure on the other measure were as widely dispersed as possible. So these are the big dots and triangles you see on the scattergram. So this way we ended up with 6 sets of 10 stimuli, and within each of these 6 sets, one of the two rates varies very little and the other varies considerably. We randomized the order of the 60 stimuli and presented them all on a single screen to listeners. Listeners had to drag the point for each stimulus along a horizontal guideline from their starting position, and their starting position was in the middle of the screen under the label average speed. They had to drag it to a position on this horizontal scale that reflected its tempo. Listeners were given an orthographic transcription of each stimulus as they listened to the audio, and they could work through the set as they wished until they were happy with the positioning of all of the dots. And this kind of interface has been used in several previous studies. The references are in the paper. So dot placement became our dependent variable, and to inform the analysis we also measured a number of parameters in our stimuli that have been shown in previous work to matter for tempo perception. Stretch duration, a measure of F0 level, a measure of F0 span, and a measure of intensity level. Our listeners also did some production tasks before the experiment, as previous work has shown that listeners' habitual speaking tempo informs their tempo perceptions, but measures derived from these tasks didn't yield any significant effects in this particular study. Now, I noted before that this experiment was one block in a larger design, which gave us tempo judgments on an additional 120 stimuli presented in other blocks. For the purpose of the quantitative analysis here, we added judgments on any stimuli from these other blocks that fitted in the quantile ranges that I've described earlier. So our 6 analysis subsets all comprise more than just the 10 stimuli that we sampled to make the analysis possible. Now we'll call the 3 subsets in the left figure on this slide here, within which segment rate is minimally variable and syllable rate is substantially more variable, stimulus set A, and the 3 subsets on the right, within which syllable rate is minimally variable and segment rate is substantially more variable, stimulus set B. Set B is the crucial one, the one we're primarily interested in here. For set A, we expected to find confirmation that listeners orient to syllable rate variation in making tempo judgments, even among stimuli that are very similar in segment rate. We modeled listeners' tempo ratings across the 3 quantile range subsets, low, mid, and high, in the figures here. For each of set A and B, with subset included as a categorical variable with 3 levels, low, mid, and high. We centered and standardized the variable rate within each of these subsets, so that's syllable rate on the y-axis in set A and segment rate on the y-axis in set B, so that we were sure that we were assessing only the relevance of variability in this variable rate that is completely independent of any remaining variability in the stable rate on the x-axis of the figures here. So here are the results. First, for set A stimuli. For subset, mid is the reference level. So the model output shows that, as might be expected, stimuli in the low subset sounded slower, and stimuli in the high subset sounded faster than those in the mid subset. Stimulus duration has a negative effect, as we found before. Longer stimuli sound slower. And F0 and intensity also have effects that might be expected on the basis of previous work. Higher F0 and intensity levels make stimuli sound faster. The variable rate here, syllable rate, also has a positive effect. Now, the model reflects that in all three subsets, stimuli with higher syllable rates are judged faster, as you can see in the figure on the slide here. So as expected, syllable rate variation that is independent of segment rate variation informs listeners' tempo judgments. For set B stimuli, in which segment rate is variable and syllable rate variation is controlled, we find very similar effects of our control variables, with the proviso that here stimuli in the high subset were not rated significantly faster than those in the mid subset. Crucially, segment rate significantly contributes to the model fit with a positive effect. And again, we can see that this effect is the same in all three, or is observed in all three stimulus subsets. So whether stimuli are relatively slow or average tempo or fast, those with higher segment rates, in other words, greater average syllable complexity, were judged as faster than stimuli with lower segment rates in a data set in which syllable rate variation has no explanatory value. So these findings confirm earlier ones regarding the relevance of stimulus duration, F0, and intensity for tempo perception, and most notably, they confirm our hunch that in listening experiments with naturalistic stimuli, listeners can be shown to orient both to a beat rate that syllable rate measurements approximate closely, and to the complexity of those syllables, or perhaps more generally, to spectral complexity, for which segment rate is one proxy. Right, that was a quick run through. Do read the paper, and if you're interested and you have questions, get in touch to follow up. Thanks a lot.